Hello everyone, welcome back to our channel. The next topic is dynamic proton NMR. So till now we have discussed that what is the effect of proton exchange in NMR signal? What is the effect of deuteration in proton NMR? The next concept is dynamic proton NMR. What is the dynamic proton NMR? Change in the nature of proton NMR with change in the conditions, commonly called as dynamic proton NMR. Change of the temperature, change of the pressure, change of the concentration, and etc. See the first example, that is cyclohexane. We are going to discuss about the temperature effect. At the room temperature, what the people are saying, chair to chair conversions are rapid. So more number of interconversions are takes place. Because of the more number of the chair to chair interconversions, we cannot recognize axial and equatorial set of protons separately. Okay, that's why all the axial and equatorial sets of protons are considered as a one set. See this one. In cyclohexane, how many protons are there? 12 protons are there. 6 protons are axial in nature, 6 protons are equatorial in nature. So at the room temperature, chair to chair interconversions are maximum. That's why we could not be able to recognize axial and equatorial set of protons separately. That's why all 12 protons are considered as only one set and going to give only one signal with the chemical shift value 1.5 delta. Okay, suppose if you decrease the temperature, what is happening? See this one, the single signal is going to converted into two signals at room temperature, at 63, at that minus 30, at minus 100 degrees centigrade. So what is happening? At minus 100 degrees centigrade, cyclohexane chair conformation is going to become rigid. There is no movement of the chair conformation. So interconversions are not possible. So interconversions are not possible means what? We can easily recognize axial and equatorial set of protons separately. If you identify separately, 6 axial protons will give one signal and 6 equatorial protons will give another signal. Okay, now that's why at the lower temperature, in case of the cyclohexane, we are identifying two signals. This is the effect of what? Temperature. Okay. So this is for your understanding. Here we have written everything. Take the next molecule. It's very important. NN dimethyl formamide. In the interviews, the people will ask you, explain whether these two methyl groups are chemically equivalent or chemically non-equivalent. How many peaks we can observe? This very important question. So everyone should remember. So what the people are saying? At the room temperature, we are identifying three signals. At a higher temperature, we are identifying two signals. And why? What is the reason? See the reason. At the room temperature, what the people are saying, whatever the lone pair electrons present on the nitrogen atom are involving in the delocalization. Because of the delocalization, what is happening? The carbon nitrogen single bond is converted into carbon nitrogen double bond at room temperature. That's why what the people are saying, at room temperature, the second structure is the predominant in nature. If the second structure is predominant in nature, here we are observing the double bond means it is a alkene kind of species or not. So because of the alkene kind of speeds with respect to O minus, this will become trans, this will become cis in nature. Cis and trans protons are always chemically non-equivalent in nature or not. That's why these two methyl groups will considered as two sets of protons. This is one set, this is another set, and one aldehyde proton. That's why at room temperature we will get three signals. It's very, very important. Simply, what is the reason? At the room temperature, we are observing the delocalization of the nitrogen lone pair with the carbon oxygen pi bond, creating carbon nitrogen double bond. That structure is dominating in nature with respect to the oxygen minus two methyl groups are having two different orientations. One is with the cis orientation, another one is with the trans orientation. We can say diastereotropic protons are going to be chemically non-equivalent. That's why they can give two signals. The aldehyde proton will give one signal, that is another one. So totally three signals we will observe at room temperature. If you increase the temperature at 130 degrees centigrade, what is happening? The carbon nitrogen single bond rotations are increasing. The carbon nitrogen rotations are continuously increasing means what happens? The lone pair electrons, whatever the lone pair electrons which we are having on the nitrogen atom, these lone pair electrons cannot involving in the conjugation with the pi bond. The conjugation is not possible. That's why the formation of this structure is not possible. That's why number one is predominating in nature. So if you have a carbon nitrogen single bond, these two protons will become chemically equivalent. Chemically equivalent means only one signal. Aldehyde will proton will one signal. That's why you will get only two signals. This is the effect of temperature. This is commonly called as a dynamic proton NMR. For your understanding, the notes is given here. So in this way, we can identify the situation. Okay, so accordingly, for each and every kind of the moiety, you can identify the effect of temperature, higher temperature and lower temperature. Here these are the some of the examples you can try. So at the last part of the proton NMR spectroscopy and C13 NMR spectroscopy, we will be having some discussion on the different kinds of the structures. How can you determine the spectra of the compound by using the data? Okay, so this is about dynamic proton NMR. Okay, thank you.